Hi, my name is Bill Gallant, and I work with Ethan Powers, and we teach the technology and engineering courses at Ipswich High School. Just going to tell you a bit about myself. My background is I'm an industrial engineer from UMass Lowell. I worked for the Postal Service and UPS designing distribution systems for a while. I worked at Malden Mills, making Polartec fleece, training workers there after the big fire they had. Then I went back to school. I got a master's in technology education from Fitchburg State, and I've been teaching in Ipswich for about 10 years. One of the things I like most about working in Ipswich is the access to grant funding that we have that have let us purchase new technology over the last couple of years, which we'll talk about as we talk about our courses. So these are the courses available: semester courses, Engineering the Future, Drafting and Design, Robotics and 3D Printing, and the full year courses are Engineering 2, Engineering Projects, and CNC Machining. So Drafting and Design is about residential architecture. So students are working as an architect, designing a home for a family on a real piece of property. So they start with studying the site, they come up with floor plans, a 3D model, and then actually build a physical model. So here's an example of some of their work. There's a site plan, a physical model, a 3D SketchUp model, and then there's an AutoCAD floor plan for a home. Engineering 2 is about using the design process to solve engineering challenges. So some of the projects we've worked on are egg trebuchets, mouse traps, lollipop licking machines. We use laser cutting and 3D printing in some projects, and remote operated vehicles, which I'll show you on the next slide. So there's some lollipop licking machines, there's some students testing trebuchets, Morgan working on an electrical vehicle. There's a remote operated vehicle, which is an underwater, a submarine that's tethered, that has to perform some task underwater. And then there's an example of a humane mouse trap. Engineering projects, students compete in a national competition called the Student Racing Challenge. So they do everything that a race team would do, from marketing, communications, race engineering, aerodynamic design, energy projects, and any engineering project that can help their race team. So these are some images from a competition that we had at the high school a couple of years ago. We actually won this event, and then students get invited to a national competition where they race against schools from other parts of the country. This particular year, we went down to Texas A&M to compete. CNC machining, new course this year. Through a Payne grant, we got an MCO milling machine that is operated by a Siemens control system. So students are currently learning how to mill programs using the Siemens shop mill program. And at the end, they will get a certification from Siemens saying that they know how to use the Siemens programming methods. Now, Ethan is going to talk to you about the courses that he teaches.
All right, hi everyone, my name is Ethan Powers. So a little bit about me before we get into the classes that I teach. I graduated from UMass Amherst in 2019 with a bachelor's in mechanical engineering. I worked at an engineering company that did inkjet stuff up in New Hampshire for about a year. Then the pandemic hit and I became a teacher here at IHS. So Engineering the Future. This is our introductory course for engineering at the high school. It's mostly freshmen and sophomores taking this class. So we go through these projects that are basically trying to teach them the engineering design process from start to finish. So coming up with some initial design, prototyping, testing, and then at the end asking yourself, okay, what can I do better? What can I fix for next time? The first project we do gumball machines. Then we do some construction projects where we make little bridges. Third project is steamboats, and then the fourth project, if we get to it, is electrical design challenges. This year I modified the curriculum a little bit, and we did a lot of Tinkercad and Onshape part design, and a lot of 3D printing stuff, just due to the hybrid model. We didn't have a lot of time to do some of the in-class stuff, so those were some remote projects that were good for the class. And there's some stuff that we've made in past classes. Robotics 1, this is our introductory robotics course. There's a robotics 1 and a robotics 2. In robotics 1, it's very guided. We start off building these claw bots at the start of the semester. And as we go through, we program our claw bots to do lots of different things. So it'll do dead reckoning, it'll do line following, it'll pick up objects and move them from point A to point B. So the kids learn programming that way. We'll also add lots of sensors, so rangefinders, ultrasonic rangefinders, stuff like that. Robotics 2 is a little bit less guided than Robotics 1. It's a little more open-ended. And in this class, kids come up with a project for themselves to do. So last semester, I had 2 groups. One group did an augmented arm that helped you lift weight up and down. And the other group did a bot that dispensed hand sanitizer and face masks through the building. And it would follow some set course to follow. 3D printing. So we actually got 8 new 3D printers. They're the ones that you see on your screen right now. So I was able to fill out the lab with lots of new printers. The structure of the class is that kids are designing parts that they then 3D print. So they're learning to design parts in CAD, and they're also learning how to 3D print and a lot about the settings and the bed leveling and how to print 3D parts precisely. So examples of projects we're doing in that class right now, we've done keychains, we've done little tugboats, we've had open-ended projects where kids print something that they find online. We've printed tool organizers, we're printing phone cases, all kinds of stuff just to get the kids as much experience as they can in the time that they have taking the class. And really my goal at the end is for them to be able to come in and if they need a part, after the class is over, if they need a part, they can design it and they can print it all on their own without any help from me. All right, so I think that's it from both of us. Here's Bill and I's contact information. I'm epowers@ipsk12.net. He is wgallant@ipsk12.net. If you have any questions about the program or anything else, please don't hesitate to contact us at either of these 2 addresses. So thank you for watching.